Good afternoon. This is our 1 o'clock session on Instagram Live on our Ohio State University Math Literacy Initiative Monday Math Day. So we already talked about making tens, place value, fractions on a number line. Right now we're about to dive into angles. So thank you for the caregivers who are tuning in. Also, we'll be posting these videos on Facebook, so you might be able to check those out. These are some of the things that we did with the earlier sessions. So let's get talking about angles. And today we're going to talk about several things with angles. We're going to talk about parallel lines, perpendicular lines, and complementary and supplementary angles. So we'll be talking about those. I'm going to use some things that I found from nature and some things that I have just around the house. So, but you can use whatever tools you have available to you. Let's talk first about parallel lines. So what are parallel lines? So I'm going to use sticks that I found on my walk. They're fairly straight. There's a little bit of difference, and that might have an effect on what we do. So just remember, sometimes your tools, we're just experimenting with these ideas. Okay, we're experimenting with these ideas and having kids figure things out for themselves. So I'm going to tilt this line just a smidge and talk about whether or not these are parallel lines. So I know a lot of us, when we learned about parallel lines when we were in school, or at least I did, it was always, well, if they go on forever, will it touch? Well, you can imagine those kinds of things, but there's a really much more structured way that you can figure out whether or not lines are parallel, and that is looking at this distance in between the lines. Now, I'm going to take another stick. This one is fairly straight, and it's important that this one be straight, and just see if these two lines are parallel. Now, if we put this line here, this chunk right here, and let's move it down. So it's right here. It's about touching these two different lines. But what happens when we go down here? When we go down here, it gets off a little. Now you could say, oh, well, you can put it like this, and they're still touching, but touching like this and touching like this is very different. So measuring or using this measurement idea to determine if something is parallel or not parallel, it's really important the way that you hold the measuring stick. So just so that it can be the same all the time, we're going to hold this measuring stick perpendicular to both of these. Now, what does perpendicular mean? So a really quick way to check perpendicularity is that it makes a right angle. So I have one of these envelopes that I use in one of my other lessons, and we're just going to check and see if it really goes into this and makes a perpendicular angle, and we'll check. So it does here. Now what that means is if this is parallel, this distance would be the same down here too. And we can see that it's going off of this line. So I'm going to adjust my lines just a smidge. So I'm going to eyeball it a little. Let's make it exactly. So this is what's called the perpendicular distance from one line to the other. So if that perpendicular distance, so if two lines are parallel, they will have the same perpendicular distance anywhere on those two lines. If we want to make two perpendicular lines, so let's say we have this line and we want to make a line that's perpendicular, what we can do is we can measure and put dots, so we know. I'm just using this to make sure that it's perpendicular. Perpendicular, perpendicular, and we know that that line that we have to put on there to make it perpendicular will have to go across this line. All right, so now we have our perpendicular lines. That means, again, let me write it down. Sorry, parallel lines. Parallel lines have a constant, means all the same. Perpendicular, I'm just going to use a symbol, distance. That's all parallel means. So it just means that it has that same distance all the way around. All right, so now we're going to look at something. I'm going to take another stick, and I'm going to put it like that. I'm going to make this one just a smidge closer. We know it's parallel, or I'm going to assume, so don't ever assume in math, but I'm going to, for the purposes of this task, squish them together a little bit. All right, now some really cool things happen when you have perpendicular or parallel lines and you have this line that goes across it like this. This is called a transversal. And so some really cool things happen. So I'm going to use just some construction paper. I cut out the corner of this construction paper so I can just make some measurements and we can just play around with these angles a little bit. So here's what's cool. I'm gonna figure out what this angle is right here. So I'm gonna put that right in there and I'm going to mark it here. I'm going to cut that. Cut it all the way to that point. Let's see how well I did. Okay, so that goes right in here. Here's the super cool thing. This, because these two lines are parallel, this is also the exact same measure as several other angles on this. So let's look and see. Is it the same as this one? Nope. Has a little bit missing off of that one. The same as this one? Nope, a little bit missing. Let's look at this one. Look at that. That's because these are called vertical angles. This one and this one. So we're just using our tool made out of construction paper to see if they're the same. So we know that this one and this one are the same. We just checked it with our tool. So now let's look at these over here. So let's look at this one. Nope, it's not okay on that one. Let's look at this one and look at that. That, I'm sorry, but just math is so much fun. That is cool. Watch this. Look at that. So we figured out that this one and this one are the same. And now we're saying I'm using the same piece of green construction paper. This one's the same, this one's the same, and this one's the same. That's exactly true. These angles all have the same measure. Now, we don't know what that measure is right now. We're not measuring it. We're playing with angles. So let's see. So we know 1, 2, this one's equal. Let's just look at this one. What do you think? Do you think that this one will be? Let's see. Nope, that one's not. And let's look at this one in here. Look at that. That one is the same too. So here's what we just found out. Just playing with our sticks, our perpendicular sticks, making sure they're perpendicular, putting a line across them. Here's what we figured out. We figured out that this angle, and we usually mark angles with an arc like this, and this angle, along with this angle and this angle, we know that they're all the same. That's just cool to me. So we know that those are all the same. So what do you think about the angles that we haven't measured yet? Let's see what happens with them. Now, I am going to use, I'm going to use this one so that we can see. So I took this semicircle just to cut off some half circles on construction paper. And I'm going to use this one to measure this tool, this angle. So I'm going to start in the middle here. I'll just make a little spot right here in the middle, because now this one, it has a whole thing, not just the right angle. So I'm going to put this right here, and I'm going to line it up along this one, and I'm going to feel for my stick. I'm going to have it right about there. Then I'm going to cut this thing off here. Let's see without my glasses. I'll do my best. All right, now, what do you think is going to happen? So let's try it. Okay, so here we have this angle. We can see that it fits right into that angle. Let's look at this. Well, we already know it doesn't work here, right? But look at this one. Cool. So now we know this angle and this angle are the same because we just measured them with our construction paper tool. So let's look at these. Is it going to be the same as the green ones? I don't know. What do you think? What do you think? Let's see. Look at that. And then look at that. Awesome. Awesome things that we can find out just by looking at 3 sticks that we made sure. You do have to make sure that the 2 sticks are parallel. But just to figure that out. And this is just an experiment that any of your students can do. So let's talk a little bit about what these things are then. So we know, and let's take another one of these. So this thing, I'm going to put a dot right here so that we know where the middle is. Look what happens. So if we put that dot right where that transversal twig, transversal twig comes from, if we put that right there, that includes this whole piece right here, this whole piece. Now in mathematics, we have degrees. We measure with degrees, primarily in the grades that we're talking about. And so we know that these straight lines all have an arc, this angle right here, that goes along with a half circle. So here's what we know. We know that this angle, this black one and the green one, let me put them up here. We know that the black one and the green one together make up that straight line. So there's a straight line that we have right here with that black one and the green one. Now, that straight line, and the fact that these 2 angles come together to make that, it's called a straight angle. I'll write that down. So it's called a straight angle. We know that those straight angles add up to be 180 degrees. Now we'll do another task on another Monday Math Day to tell why we know that. But it matches up to 180 degrees. So that means that any of these, if all the blacks are the same and all the greens are the same, any of these could add up to be 180 degrees. So that's called angles that make up 180 degrees are supplementary angles. So our green angle and our black angle are supplementary angles. All that means, all supplementary means is that they add up to be 180 or a straight line. 180 or a straight line. Everybody knows what a straight line looks like. Now we just have to remember a straight line's 180 degrees, because think about, like, sometimes you go to sites and they give you like 360 degree visual on, like, if you're going to visit a site, going to look at a house, like on your app, and they'll say a 360 version. 360 is all the way around. So all the way around is, if we start here, we go all the way around. So if we went all the way around, that would be 360, just like it is when you are looking at something maybe on the internet or something and they say a 360 view or something. So, but half of that we know, so 360 divided by 2 is 180. So that's this semicircle here. So those are supplementary. So we can figure out any supplementary angle. We just need to remember that 180. Easy peasy. So remember, it's 180. Let's look at these angles. Now, there are also angles called acute and obtuse. So here, acute little angle is smaller than 90 degrees. 90 degrees is any corner like this. Usually on a piece of paper, you can pick up any piece of paper. I can use my pink and get this. There's a 90 degrees. So let me look. I'm just going to tear this off, this corner off. And let's see. Now, let's look at the black angle. Is the black angle acute angle? No, it's not. It's not acute angle because it's bigger than this 90 degrees. Let's look at the green angle. Is the green angle acute angle? Yep, we cover it all up. So if you can cover it all up like this, that's called an acute angle. That really just means less than this 90-degree angle. All right, so that's the name for an acute angle. Now, we said that this black one wasn't an acute angle, so there has to be a name for that one too. And so this angle, this black angle, because it goes beyond our 90-degree check, that's called an obtuse angle. So an obtuse angle is greater than 90 degrees. All right, now we have this, which is our 90-degree angle, and that's called a right angle. All right, so we have our right angles. So let's look at right angles for a little bit. I'm going to pause just for a second so that you can see what we have here. We put our parallel lines together. We figured out the relationship between the angles that are within those parallel lines. Let's now play with something else. Now, if people are watching real time, you can send in some questions and we'll try to help you out. All right, so now they have this. So we talked about supplementary angles. Supplementary angles are the angles that add up to be 180. There's this other kind of angle called a complementary angle. So what are complementary angles? So I like to think of, we use words in mathematics, and sometimes there's similar words that we use just in our everyday life. So I like to think about complementary angles as, so if I have a friend and we like to compliment each other. So I have a friend, Debbie, and she's really nice. She's a mathematician too. Well, we're all mathematicians, but we compliment each other and we say, oh, I like that outfit on you, or you did a really good job at this. So when two friends are complimenting each other, it just feels good, right? It feels right. So complementary angles, they feel good. It feels good to get a compliment. And when something feels good, it feels right. And this is what we know a right angle is. So if we have a right angle, and we know that it's right because let's check it again. We know that it's a 90-degree angle, so the 90-degree angles are right angles. So we can figure out any angle that would complement another one. So think about it like me and my friend Debbie, or you have somebody who you have as a friend, and it just makes you feel good to be around them because, you get along, you give each other compliments, you also give each other criticisms when it's important or necessary, and that's okay too. But let's say this is one of the angles. The complement to that angle is the one that makes it feel good, feel right. So here's the complement to that angle. Now, we could put numbers in here if we want, but really just figure out what these words mean first. Let's just think about what they mean first. Once we know what they mean, then we can move on from there. So we could put some numbers in here because we know that a right angle is a 90-degree angle. But for right now, let's just play with the relationships between angles that we see. Excuse me. So how do we find other relationships between angles? I went out on my walk, and I found some twigs. I'm going to erase this. I found some twigs and some angles in nature. Nature has cool angles all over the place. I'm just going to pick up one of them. So it kind of looks like a person, huh? Put a little noggin on it and make a person. I'm going to stick this up here. I have this tacky gum stuff that you can stick things on. I know most of you don't have that at home. Maybe it's just I used to use this a lot when we were working in Haiti. All right, I'm going to stick this one on there, and then I will put this one up here. Thanks for being patient. I appreciate it. All right, so we have this stick. Now, we can talk a little bit about the angles that we see in this stick. So, what do we know? We know that when there's a center piece like this, we know that all of these angles around here will add up to be that full turn. And that full turn, think about the pictures and the videos that you see, that full turn is 360. Because a lot of you remember 360 degrees. So we know that this angle and this angle and this angle, oops-a-doodle, and this angle all give us 360. So why is that important? How is that valuable? My stick is not cooperating, so let me put it up there just a little bit better. All right, so we know that the red we know that this angle and this angle and this angle all together would be 360. So if we know one of them, actually, in this case, we would need to know a couple of them, but we know that they're sums. That means when we add them all together, it'll be 360. We also can tell some things about whether or not they're acute or obtuse. So I'm just going to hold it since my stick is not cooperating. So what do we think about this one? So is this an acute angle or an obtuse angle? I'm going to use my tester. Okay, so what does that mean? It's less than right. That means it's acute. What's this mean? More than right. That's an obtuse angle. What do you think about this one? Take a guess first. Okay, let's see. I'll put it behind so we can see that it goes beyond our pink. So this is acute, and here, bigger than our pink. So that's obtuse. Now, when we worked with the parallel lines, we could look at angles in different places and make some comparisons. But that doesn't work on this one. So here, that's acute. We can tell that this is a straight angle, but we don't have any angles that are equal to each other because we don't have that idea of two parallel lines together. But we can talk about what different kinds of angles are here. Now, for something that you can do with your students at home or your children at home is to have an angle scavenger hunt. So find angles around the room that have, maybe you could say, find an angle that is acute, find an angle that is obtuse, find two angles that together are complementary or supplementary. And if your child has a phone, because these are going to be older children for the most part, they can take pictures of their different items, and then they can come back to you, show you their pictures. Every student I know, child I know, likes to show you their pictures, and they'll get excited about it. So it's much easier, much nicer. We want to play with these math ideas, not just do them. We don't want to just do it. Let's play. Let's play with them and see what we come up with. So we're going to be posting this video to our Facebook page. If you try some of these things out, or if your student finds some really cool angles around the house, post it to our Facebook page and share it underneath this video. We'd love to see what you're doing at home with your students. Thank you for your time. I know your time is incredibly valuable, especially now. And just love and peace to you and your family. And we hope to see you next Monday for Monday Math Day. Have a great day.